All right, I think we're gonna get started. Welcome to Experiences Scaling File Storage with CephFS and OpenStack. My name is Greg Farnham. I've been working on Ceph for about 8.5 years. I previously served as the Ceph file system tech lead. I'm in the core team, Rados team now, and I got drafted to serve as the moderator for this little session. We'll go down the list.
Yeah, my name is Sage Weil. I'm the Ceph project lead. Have been for a while.
My name's Tim Bell, and my team run the CERN Cloud, home of the Large Hadron Collider.
My name's Rafael Lopez. I work at Monash University as one of the DevOps engineers there, and I've been playing around with Ceph for about 3 years now.
Hi, I'm Patrick Donnelly. I've been with the Ceph team for 1.5 years now, and recently became the CephFS tech lead.
All right, so, and here's this nice intro slide, sorry. Right, in front. So OpenStack Vanilla is the file system as a service project in OpenStack. It has a role analogous to that of Cinder, where there's sort of it's a management layer that's responsible for plugging your VM or providing your VM with access to file systems which are served up by something else. It started, about 3 years ago, I think, maybe 4. It was very interesting when we sort of started hearing about it. Unfortunately, the Ceph upstream team didn't have a lot of time to devote to anyone working with it at the time, especially because it seemed like it was a lot of big box vendors who were trying to sell their storage boxes into the system, into the OpenStack system. But it was something that we wanted to be involved in when the file system was ready for people to actually start using it. So that's what it does. So we were very interested. Sage will talk a little bit more about the initial draft driver we had, but we were very interested when the survey came out for the Boston Summit to see that without our really having done any evangelizing, we had rocketed up to this huge usership share inside of OpenStack and inside of Manila. But I mean, it sort of made sense. Ceph is the #1 storage solution for cinder block devices. People wanted a file system. We said, hey, we have a file system that you should try out. And I guess a year and a half ago, we even told them it was stable and ready for people to use. So they said, all right, we have a stable file system. It works with our storage system that we already know and trust for block devices. And it's sort of got a lot of cloud features that we like. So we're very interested in moving forward with it. So that's why we want to integrate it, and I guess Sage is going to tell us a little bit about how it worked.
Sure, I'll just use this one. Okay. Is there a slide for it, or?
Yeah.
So the initial driver that we wrote for Manila is pretty simple. It's kind of, I guess, what you expect. It allows you to use the Manila APIs to create shares, which are actually subdirectories in CephFS, and then attach them to your VMs. And the way that it does that is not using NFS like all the other drivers, but it lets you use the native CephFS driver in your VM. So this gives you the best performance. It's sort of the simplest thing. It's the Ceph-y thing that you would sort of expect to happen. The caveat is that your tenant VM has to have access to the same network that your Ceph cluster is on, because it's talking the native Ceph protocol between the client and the Ceph storage daemons. Despite that, it's widely used. It seems to work pretty well. Tim will probably talk about a bit about how he's deployed that in the CERN cloud. Yeah.
Well, so there's that other. No, sorry. Yeah. There was this other thing you touched on, which is that you said it speaks the native CephFS protocol out from the client, right? So that probably comes with its own set of challenges.
Yes. So the reason why that matters is because it means that when you're talking to the native protocol, that means that the tenant VMs are talking on the same network to all the storage, the Ceph daemons. So that means that the VMs have access to the storage network, which might have other things on it. And it also means that you're relying on CephFS for all your security, which isn't strictly different than an NFS case where you're talking to an NFS server and you're relying on the NFS server implementing all the right security restrictions. But CephFS has a much broader surface because there are like hundreds of daemons, and it's not as mature as the very narrow interface that NFS provides. So that security model isn't always appropriate for all situations. So for that reason, we're also looking at other NFS-based approaches as well. But for lots of environments, this works great, as is attested to by the fact that it's pretty broadly deployed.
I was actually thinking about having the clients.
Oh, right, and the other thing is that the VMs actually have to be able to mount the file system, so they have to run a reasonably modern kernel because they're talking the Ceph protocol to the system, or they have to run Ceph views. Yeah, so you can't do like Windows VMs talking to CephFS, not today.
Great. So for the CERN installation, we've got a multitude of different storage solutions. There's about 200 petabytes of storage at CERN on disk. And we were looking around for a solution that would allow us to have a POSIX-compatible file system. In many cases, the storage solutions we were developing were POSIX Lite, but in some applications, for example, in the high-performance computing area, or in areas where we were taking clusters of solutions where we didn't need to have a large-scale storage solution, we were looking around for something simple to give to a chunk of VMs. So with that, given that we had a significant installation of Ceph already, it was very easy for us to then be looking to use CephFS more widely. Currently, there are about 70 shares that we allocate out from the OpenStack cloud towards VMs. And the benefit for us there of using Manila was that all of the standard workflows, the quotering, the accounting, the security permissions, will integrate into the existing OpenStack project structure. The single pane of glass for people made it very easy for them to come along and just click on the GUI. People were very familiar with the tools already, and therefore it was a very rapid onboarding for our end user communities. So, I mean, in general, we found that the community's been very responsive, and things have worked basically out of the box nicely for us. Looking forward, we'll cover a few of the points in the ongoing discussions also around areas where we are interested in seeing enhancements in future.
So, Tim, can you tell us if you've encountered any big problems in production, or if you have pain points with the native Ceph driver while you're testing this and running it?
So in terms of the deployment, it was actually very smooth. I think in total we found 3 problems, and they were the kind of things that as you push a storage system to multiple levels of directories, we were finding little hiccups there. All of those got fixed and have now been resolved. So that went very smoothly. In terms of things as we've been running, I think most of the time we found that the functionality matches exactly what we've been expecting, i.e. classic POSIX. There are a few areas around the security, around quotas handling in the kernel drivers, are areas that we'd be interested in improvements, along with potentially snapshotting.
So I'll talk a little bit about Monash. So for those that attended the keynote, you would have seen a little talk on the Nectar Research Cloud. Monash is part of that research cloud, along with 7 other institutions. We actually have 3 clusters at Monash, one which we use strictly for storage file shares, and the other 2 are underpinning the Nectar Cloud. In terms of Manila, we're actually pretty fresh with Manila. We only configured it about a month and a half ago, and we're sort of just playing with it at the moment. But similar to Tim, we found it very smooth to configure. A couple of little hiccups that weren't, documented very well, but nothing major. For our big CephFS cluster, and in general, I guess all of our compute and storage resources, they're used for quite a wide range of different research activities from different disciplines. So not so much, very focused research on one thing. So we don't really know, how many users are out there of our storage, and we give out shares, but then they get reshared, and we just a little bit concerned about quotas, for example, because we understand that with the kernel client for CephFS, you can't actually control, you can't enforce the quotas. So while we can ask our users to use the Fuse client, which does enforce quotas, we really can't be sure because our researchers are pretty cluey and they can go off and find out that they can use the kernel client as well, and there's really no way to stop them. So that's kind of one of our concerns at the moment.
Yeah, you mentioned on the slide that a lot of people, or you suspect people are doing vfilers. I assume that means a VM exporting RBD via NFS. I guess the question for both of you actually is that something that's pretty commonly done in your environment? And yeah.
Yes, so certainly we have a significant number of scenarios where we do an NFS export in particular, because that also allows us to have things like Kerberos support through the NFS gateway. So we can add additional functionality on top. For the end users, in many cases, they require some form of NFS access because there may be commercial software that requires a POSIX-compatible client. So therefore, it forces us towards an NFS environment.
I think in our environment, it's more a case of them wanting shared storage between instances, and that's the only way at the moment. So until we get Manila fully configured.
So what I'm going to talk about now is kind of our future direction for integrating CephFS with OpenStack and other deployments. The CephFS team has come to OpenStack several times, talking about various strategies we've been looking at for actually doing this integration, including the native CephFS driver, which has certain issues regarding the older kernel clients having old kernel bugs that we've since fixed and not integrating well with the with Ceph, and then also the security related issues with the tenant VMs talking to Ceph directly. Some of the approaches we've talked about in the past included the hypervisor mediated access to the Ceph cluster by putting, for example, NFS Ganesha in the hypervisor, and then using, for example, VSock to connect the VM to Ganesha. We've also considered having service VMs in the OpenStack cloud, which Ganesha in those service VMs, and then connecting to the clients that way. But what we've found recently is that we're going to want to go in a direction that allows us to put NFS in multiple put NFS and connect it to Ceph and have this available in multiple orchestration frameworks and deployments, including Kubernetes and OpenShift. And then also in standalone Ceph deployments, we want to be able to have a Ceph cluster that allows clients to connect over NFS, so that we don't have to worry about older NFS clients and then or older kernel clients, and then also allow the operator to isolate the clients from the Ceph storage network, and thereby it's solving the security issues. So right now, what we're exploring is developing an HA strategy on top of Kubernetes, putting the Ganesha VMs or Ganesha in a container that's in Kubernetes, and then connecting that directly to Ceph. And this is part of a overall strategy with putting Ceph in containers to allow, for example, hyper-converged architectures where you have OSDs running alongside Mons on the same bare metal, but in containers. And so we want to use the Kubernetes existing HA for Ganesha, so that we can have the same HA strategy across multiple deployments, in either an OpenStack or an OpenShift, or then also having Ceph as a standalone storage appliance that offers NFS to legacy kernels, or just be isolated from the rest of the computing deployments. So the what we have on the screen is the current proposed architecture for this framework, and it involves having the Ganesha in these Kubernetes containers, and having Manila talk to the Ceph manager. Oh, I have a pointer. Okay. So the Manila would talk to the Ceph manager to actually create these different shares, and the Ceph manager would actually perform the container creation by talking to Kubernetes and a network driver which connects Kubernetes and OpenStack, and actually create these NFS gateways, which what we're calling this integrated Ganesha solution with Ceph. The manager would allow Kubernetes to actually manage this HA, so this allows us to let Kubernetes manage the IP failover, which is the main issue with HA and Ganesha, and actually handle the respawn of Ganesha if it fails. On our side, this makes things much simpler. So I think that's all I got to say about that. So.
I guess it's a quick question. Want to just talk briefly about what the courier bit is there? Is that?
So this is still very much a work in progress, but the courier bit here is what we're going to use to actually connect this into OpenStack, I believe, right? And so the Manila would actually pass the neutron network that you want to attach the share to, and then the Ceph manager would use courier to with Kubernetes to actually connect the container that Kubernetes is going to create to the neutron network share.
All right, Sage, can you talk a little bit about what you view as if there are drawbacks of actually putting NFS in front of Ceph, or if you think that's a good world to move towards, or the world we live in?
It's the world we live in. It's not the world I imagined years ago. The whole point of designing the CephFS protocol was to do something that was better than NFS. And to a large extent, if you're running modern distros, you tend to get up-to-date kernel clients. But there's still people who run old kernels, and then you end up fighting with the customer because they're on like a 4.4 something and they have some driver, whatever. So the reality is that in the real world, there are environments where you just have to speak NFS, and so there's not really any getting around that. NFS Ganesha is a nice choice because Ganesha has its own plugin framework, and so we can plug the libCephFS driver directly into the Ganesha process, and so it's an efficient gateway. But it is still an extra hop because the clients talk NFS to Ganesha, and then that translates to stuff on the back end to Ceph. So there's going to be some loss of performance. You're always going to be better off using the CephFS kernel driver if you can, but if you don't run a modern distro or a distro that updates their clients religiously for Ceph, there aren't very many that do that, then NFS is there for you.
All right, so I'm going to push back against that a little bit. I think that CephFS is a great protocol, but there is something that you sort of left off there, which is that CephFS is a very coherent protocol. Clients can, and it has very coherent caches, so clients can cache a lot of data locally, and they have sort of distributed leases from the servers that allow them to do that. But one of the consequences of that is that misbehaving clients are malicious clients. If they can read something, they can prevent anyone else from updating it. And so I think that's a problem in public clouds. There are things that I know the team is working towards to deal with buggy or malicious clients like that, where you get a timeout period and then they get booted and things. But I'm not sure that's ever going to be good enough for a public cloud. Do you have any thoughts about that?
Yeah, I think that's accurate. I think that the way I would frame it is that CephFS is stateful. So clients get these leases, and if they don't release them when they're supposed to, then everybody else has to wait. NFS is also stateful. The new versions, NFS 4, has the delegation stuff. So if you're supporting NFS 4, you could do the same thing. But in a cloud environment, you can just disable delegations if you want to, and so you could prevent malicious clients from doing a DDoS. So I think there are those environments where you really have untrusted tenants where that matters. But I think there's also a large category of environments where you don't care about malicious clients so much. CERN is probably a good example where it's not so much that you're guarding against somebody who's like trying to do the wrong thing, but that you're guarding against an application that went haywire or a user was uninformed and made the wrong choice. Does that sound right?
Yes, I mean, a lot of the cases is a question of protecting the users against things that occur by accident, and then being able to trace to see who was it who had the accident.
Okay, so that's about 20 minutes, about half our time. At this point, I have a long list of questions that we can go through here, but if there's questions from the audience, it's a very large room, so you'll have to shout loudly, but if you want to raise your hand, we can start taking questions from the audience, and we'll repeat them through the mic and hand it down. Yes? All right. All right, so the question was whether when we say quota, we mean storage quota or bandwidth quota. And sadly, the answer is that we were talking about storage quotas right now. And that sort of comes with its own challenges. Patrick, do you want to talk about that, or?
So for storage quotas, the issue we've had is that the kernel client doesn't do it, and the main problem technically for that is the kernel client would need to traverse all the parents for a given inode in order to figure out what the quota is for the containing directory with the quota, which is not a feasible thing to do in the kernel because of the locking situation you would need to implement. So right now we're looking at alternative mechanisms for the next release of Ceph in order to actually get that to work. And we have a promising solution that we're investigating now that involves reusing some of the ideas we've had with snapshots and CephFS and then applying them to quotas, because the observation is that snapshots also work on subtrees, and then also we can apply that to quotas because quotas do the same thing.
Yeah. So in terms of bandwidth quotas, that's generally what we refer to as QoS, quality of service. So there's sort of two things going on that need to happen there. One is that the underlying RAIDO system would need to support quality of service, and there's work going on to do that right now, but we're not sure when it'll be done. The other option is that this is the case with RBD2. RBD actually does not support quotas on its own, or sorry, does not support QoS on its own, but there's this nice thing where QEMU you can configure QEMU to have either bandwidth or IOPS quotas, and they just apply them on the client side. And unfortunately, I don't think any of us are familiar with any way of doing that with file systems in the Linux kernels or elsewhere, so none of that exists right now. So Tim and Raf, do you want to talk a little bit about whether you encounter either or both of these problems? And
certainly, it's a worry for us as we roll out a service. In the case of the CERN environment, we've been only documenting and rolling out the Fuse clients because that way we can enforce the space quota. Of course, the end users could always discover how to do the kernel version without any problems. They're knowledgeable enough to do so. But currently what we're looking at doing is deploying the Fuse clients, which then allows us to impose the limits. The bandwidth limitations is certainly a worry for us, especially because the CERN total Ceph environment is petabytes of storage, and therefore you can potentially absorb an awful lot of IOPS within that. So we keep an eye on things, we do a fair amount of monitoring, and then that way we pick up anyone who is accidentally using up more than they should be. In the case of CephFS, the only time it's happened is when we were doing a stress test. We did a stress test of Manila, and unfortunately in doing so created quite a lot of load elsewhere around the CERN network. Arne talked about this in Boston, when they were doing a large-scale test.
Because I guess we haven't had Manila there that long, we haven't given too much thought about quality of service bandwidth stuff. But we've certainly thought about the storage quotas and the kernel client and how we can potentially solve that. And at the moment, the best that we've been able to do is to just write a little daemon that sort of keeps track of quotas and basically alerts us when quotas are hitting watermarks. But at the end of the day, yeah, we can't stop the client from writing. There's certain things you can stop the client from writing to the cluster. There's certain settings and things you can do there. But I think there might be a few bugs or things that don't quite work in the current version we're using, which is the Red Hat Ceph 2.4, 2.3, 2.4. So we're pretty keen to get Red Hat Ceph Storage 3, which is based on Luminous, and I think those things will be ironed out, and then maybe we might have a workaround to actually disconnect clients and just stop them from writing completely.
All right. Other audience questions? Do you see anyone raising their hand? Oh, yes. All right, so he points out that NFS is also nice because it integrates both Kerberos and Ceph does not right now, and he wonders if there are any thoughts or work being done on that. Sage, would you like to address that question?
I'd love to. So the Kerberos comes up, and we sort of talk about it perpetually. There are sort of two main phases, I think, of the Kerberos integration. The first phase is the simplest one, where we want to have Kerberos authentication for administrators with role-based authentication controls, so you can have administrators who are granted access to administer the Ceph cluster via Kerberos, and then that grants them the ability to use the Ceph CLI to do whatever, and then you can revoke it. That's sort of the phase one piece, and that's in progress. Slowly, we're working with some folks at SUSE to get that implemented. The second phase, which I think is what you're after, is user authentication for users who are writing to a CephFS file system. That's something that we've also talked about, and we have sort of a rough sketch about how it's going to work. But it's definitely phase two. It comes after we do the initial stuff. And there's work that has to happen with the CephFS protocol so that a given client that's already mounted the system will dynamically set up additional authentication for individual users that then let them access certain shares or whatever. So it's more work to be done there. But CERN is actually one of the environments where they're heavy Kerberos users, and so we've talked a lot with them about sort of developing what the requirements are. Mostly it's just lacking sort of the motivated engineer with the necessary expertise to help work through the issues.
Yeah, so at CERN, we're, as Sage mentioned, very big Kerberos and AFS users. So what we're looking to do for the use cases where we're looking with CephFS is to have the trusted clusters being able to mount directly with CephFS, and then arranging Ganesha and FS exporting of that with Kerberos enabled at the Ganesha level. So that then with that, we can have random laptops, Macs, accessing through those NFS gateways and limit the access to CephFS only for trusted clusters. And that way we give end users Kerberos access to the data that's stored in CephFS.
All right. I don't see anyone raising their hand. So Sage, I've got another question for you. I think I remember a couple years ago when you announced it, when you stood up at OpenStack and announced the native CephFS driver, you also talked about how the next phase was going to be this cool thing called VSock that lets you plug directly into like a local NFS system without doing any configuration. And that is not on these slides anywhere. Can you talk about why, or if that's still in the pipeline?
Yeah, it's reality. VSock sounded super cool, and I still think it would be a really nice way to do it. There are sort of two reasons why it never happened. The first, actually Patrick probably knows more about this, was just friction with getting the VSock support for the Linux kernel client upstream in Linux. So there were motivated people sort of trying to push this view forward, but it's a sort of an obscure thing as far as the larger Linux kernel community is concerned, and they didn't really want to do it. So that's the first problem. The second problem is that even if we did do it, the model that we were imagining was that the VM is running on your hypervisor. It's mounting NFS over VSock to an NFS server that's running on the hypervisor, like sort of managed by libvirt even. So there'd be a Ganesha instance that's paired with your VM that's acting as the NFS gateway. But that means that you have an entire additional process associated with your VM. These are sort of dynamically attached shares. There's going to be additional memory and CPU footprint associated with that. And there were concerns about whether that would be feasible and practical and desirable, I guess. Am I missing anything, or? Yeah, so that's why. It's too bad.
All right. Since no one else is raising their hand, I guess, Tim, do you have any? Oh, Raf, you got some questions?
So one of our challenges, which we haven't actually come to that point, but it's actually backing up a huge file system. And I'm just wondering if you guys have given any thought to that from the point of view of the Ceph cluster and CephFS. For example, doing something like multi-site asynchronous replication or some sort of feature like that that might assist with backup, because a lot of storage arrays do that sort of thing where you can do snapshots and then replicate to another site, and then that's enough to cover you for disasters and to roll back a certain amount of time if you want an older copy. So have you got any plans for?
So we don't currently have any plans for that. What we would normally say is use rsync, but we recognize that for a very large file system that is not always feasible. So some of the approaches we might take to deal with that is to integrate that into the MDS and allow you to stream the updates to the file system in some way such that it can be replicated to another site. Another option would be to provide a framework to assist rsync in order to identify which directories have been changed, and thereby allowing you to speed up any incremental updates on a remote site. And that's probably the approach we would take.
Just to say that the requirement is also one that we have at CERN as well. So there's, in some cases, ephemeral cluster storage, like in the RHPC environment. But clearly, if we're storing our data for GitLab on the NFS cluster, on the cluster, you need to be sure that there's a way of getting the data back if there's a problem.
Greg actually was just telling me earlier that there's a community project that I believe we think exists, because CephFS has these recursive statistics that you can use, among other things, to identify whether a subdirectory has had any files changed nested anywhere beneath it in the file system. And so this script would look at those to identify where the changed files are, and then sort of do an efficient search of the file system to identify what files have changed, versus just vanilla rsync, which has to do a whole pass. So that's another approach that sort of a short-term immediate solution, I guess. But I think the bigger question for me, which I guess actually is a question for all of you, is that when we've been thinking about disaster recovery for file systems, it's been generally in sort of a loosely consistent, eventually consistent sort of framework, whereas when we talk about DR for RBD, huge amount of engineering effort involved and invested into making it a point in time replica, so that if you have a VM that's actively scribbling on the block device and it dies, the version that's in the DR cluster is a point-in-time consistent perfect copy as if the VM had crashed a couple seconds earlier, so that you can do, your database will recover and so on. But when we think about the stuff, the DR in terms of file systems, it's usually, people want like multiple directions and they're just like writing random files, and we just want the files to eventually appear on the other side. But my question really for users is like, what is the consistency model requirement that you would have when you are talking about file system disaster recovery? So I'm curious what you guys think, or I don't know what.
I mean, in our case, we have 2 data centers, one in Geneva and one in Hungary. So doing synchronous replication between sites with that sort of level of latency would be a real problem. So certainly something when we're working on a file system basis that was getting to a reasonable consistency level would be what we would be looking for.
I think in terms of requirements, I suppose we would want to be able to recover even something like a daily replication would be fine for most of our cases, if not all. It'd be nice to have more than that, but that would certainly be enough.
On that same vein, I have a question for Tim, because the model that I see a lot of end users moving towards is, for lack of a better term, it's more like the Dropbox model, where it's sort of casual sharing of files and directories, and there's no it's not synchronous, and it's actually possible to have conflicting updates if multiple people are sharing the file and they both update it. And the way that that's resolved sort of in the sort of cloudy user-facing stuff is just that you have a whole revision history, so if there's a conflict, you can roll back and you can examine both copies and sort of move forward. I know that CERN has been playing a lot with OwnCloud. What do you guys see as sort of the direction that your users want and that you would like to go?
So we've been using OwnCloud certainly at scale. We actually back it with an alternative storage solution, so it's not based on top of CephFS. But OwnCloud itself is very attractive for us in terms of its sharing nature. The physics collaborations are 3,000 people, and they're often simultaneously working on analysis together. So at that point, having something where there is a Dropbox style syncs with your laptop but doesn't guarantee complete consistency is something that our users have been very, very happy with. I think there's still a need for a cluster POSIX-like file system for other use cases. And those are generally cases where we have cooperating VMs accessing a single consistent shared storage. So I think probably it's one of those things where it's good to have a number of solutions, and then we just need to find a good way of layering them together so that we don't have to administer tens of different storage solutions at the same time. Does that cover?
All right, so it looks like we've got about 2 minutes left. Any last questions from the audience? Nope. Oh, yes, please. Cool. So can you, he was saying that he would like the sort of scanning assistance.
Yeah.
Yeah, so. Yeah. Yeah. All right. Was there a question there, or just that? Okay, no, that's fine. Yes. Thanks. All right. Well, with that, I think we're out of time unless someone wants to do something in the last 30 seconds. All right. Thanks very much, guys. It's our pleasure to talk to you.